Okay, now in this video I'll go through something called implicit differentiation. But before we do any differentiation, let me try to just give a brief introduction to what an implicit function is. Now we see in functions like say y equals x squared plus 2x plus 3, let's say it's a quadratic function, and we would say that this is an explicit function because y is defined explicitly using x. So if you know a value of x, then I can figure out a value of y. Or if we have something like say y equals x plus sine x, once again y is defined solely on terms of x. An implicit function would be, or an example of an implicit function would be something like this. Let's say we have x squared y is equal to x plus y. And in this case, I cannot define y solely on terms of x. And we said, and this is a case where you would use implicit differentiation if you wanted to find what dy over dx is. Or another example might be something like say x squared plus y squared is equal to x sine y, let's say, for instance. So, and generally the easiest way to spot it is if you cannot make y the subject of the equation, then it's a case where you might want to use implicit differentiation. And once I go through more examples, I don't think spotting them will be a problem. Okay, so let's take an example. Let's say we have some function like this. Let's say we have x squared plus y squared is equal to 5x. And in this case, I want to find what dy over dx is. And to differentiate this, what we do is we say, let's differentiate both sides with respect to x. So what's the derivative of x squared? We know with respect to x, x squared will be equal to 2x. Then I want to differentiate y squared with respect to x. And when we differentiate y squared with respect to x, I get 2y times dy over dx. And I'll explain later, probably in the next video, how we get this dy over dx term. But in this video, I just want you to be able to just do this. I just want you to be able to find what dy over dx is. And when we have a y term, since we are differentiating with respect to x, you treat the y squared, well, what do you get if you differentiate y squared with respect to y? Then you get 2y. But since I'm differentiating with respect to x, I have to tack on this dy over dx term. And I'll explain later how we get this dy over dx term in there. Then differentiating the right hand side, I get differentiating 5x, I get 5. I can make dy over dx the subject of this equation. If I take 2y dy over dx, that's equal to 5 minus 2x. And then dy over dx will be equal to 5 minus 2x divided by 2y. And that's dy over dx for this equation. Okay, let's take another example. Let's say I have x plus y squared is equal to x squared plus y cubed. And once again, I want to find dy over dx. Now, once again, differentiating the left hand side with respect to x, I get differentiating x, I get 1. Now differentiating y squared, if I was differentiating with respect to y, I would get 2y, but since I want to differentiate with respect to x, I have to add on this dy over dx. And then differentiating the right hand side, the derivative of x squared, that's equal to 2x, and the derivative of y cubed would be 3y squared. You differentiate it in the normal way, but since this is y, I have to multiply that by a term dy over dx. And once again, if I want to make dy over dx a subject, bring all dy over dx terms to the left hand side. So I'll write this as 2y dy over dx. I can subtract this term from the right hand side or bring it to the left hand side. That gives 3y squared dy over dx. That would be equal to 2x. Bring the 1 to the other side, 2x minus 1. And now dy over dx is a common factor. So I can take that common factor out. So I get dy over dx times, I have 2y minus 3y squared, because that was a dy over dx was a common factor, so that's equal to 2x minus 1, and then I can write dy over dx will be equal to 2x minus 1 divided by this term right here. That would give 2y minus 3y squared. Now you can also get implicit differentiation with the product rule. So let's take something like this. let's say I have x squared y is equal to x plus 2y. And here I have a product rule. I have x squared is my, if you want to think of it as your u term, and y is your v term, so you have to use the product rule. And just in case you don't remember what the equation, what the formula for using the product rule is, it's given by u dv over dx plus v du over dx. Now differentiating the left hand side, I have u times dv over dx. So the first term times the derivative of the second. The first term is x squared. And what's the derivative of the y term? The derivative of y with respect to y would be 1, but since I want to differentiate it with respect to x, I have to add on a dy over dx. So that's the first part of it. That's the u dv over dx part. Then I've got plus, oh sorry, this is not a plus here, this is a times. That's a multiplication there. Then I've got plus v du over dx. V, that is equal to y times the derivative of x squared with respect to x, that just gives 2x, and that is equal to the derivative on the right hand side. So differentiating x, I get 1. Differentiating 2y, that would give 2, but since I'm differentiating y, I have to add on a dy over dx term. Okay, now once again I can make dy over dx the subject by bringing all the dy over dx terms to the left hand side. So I get x squared dy over dx minus 2 dy over dx is equal to 1 minus, bring the 2xy term to the right hand side, I get minus 2xy. Now once again dy over dx is a common factor, so take that out. So I have dy over dx times x squared minus 2, that's equal to 1 minus 2xy. So dy over dx will be equal to 1 minus 2xy divided by x squared minus 2. Okay, I'll take one more example, and this time let's involve just one trigonometric function as well. Let's say we have something like, say, y times the sine of x is equal to x squared y. Okay, now differentiate. Now there are two product rules here. The right hand side is a product and so is the left hand side. Now using u dv over dx on the left hand side, what do we get? So I have u, which is my y, times the derivative of sine x with respect to x. So that gives the derivative of sine x is cos x. So I have y cos x. Then I have plus v times du over dx. So I have sine x times the derivative of y. So the derivative of y is dy over dx. Or you can think of it as derivative of y with respect to y is 1, but I got to multiply that by dy over dx. Now the right hand side is u dv over dx again, so I have x squared times the derivative of y, which is dy over dx. Then I've got the second term y times the derivative of x squared, that gives 2x. And if I want to make dy over dx the subject, I got to bring all dy over dx terms to the left hand side. So I got dy over dx times sine x minus x squared dy over dx, and that's equal to 2xy minus y cos x. Dy over dx is a common factor, so I'll take that common factor out and I'll write that as sine x minus x squared is equal to 2xy minus y cos x. So dy over dx would be equal to 2xy minus y cos x divided by sine x minus x squared.